Hello, welcome to my math channel, and today we're going to be going over first order linear differential equations, integrating factors. That's a mouthful. But anyway, so this is an introductory topic to differential equations. Integrating factors are usually introduced at the beginning of an ODE class, and they're fairly easy and pretty simple once you get the hang of it. I think I even learned this in my AP Calc class in high school. But anyway, yeah, once you get the hang of it, you can start bopping these questions without a sweat, and it's like, they're pretty fun as well. Okay, so before we get into solving the equations, I would like to kind of go over what a first order differential equation is. So to start, I want to explain what is a differential equation. So a differential equation is any equation made up of an unknown function y of t and its derivatives. So that means it'll be a function made up of, wrong tool. Let's get my pencil here. It'll be made up of, say, a function y of t and all of its derivatives. So y of t, y prime of t, y double prime of t, etc. Yeah. So the equation will be made of any combination of y of t and any of its derivatives. It depends on the order of the differential equation, which is the order of the highest derivative. So when we say we have a first order differential equation, the highest derivative will be the first derivative. If we say we have a second order differential equation, the highest derivative in the equation will be y double prime. So for example, a first order differential equation would be something like y prime plus 3t cubed y equals cosine of t. This is a first order differential equation because here we have the highest derivative, y prime, thus this equation is first order. Okay, that was pretty simple. Now that we understand what a first order differential equation is, we can start talking about the subclasses of first order DEs. Now, there are three subclasses of first order differential equations. There are linear equations, separable equations, and exact equations. And today we're going to be talking about linear equations. I'll talk about the other two in other videos. So a linear differential equation is pretty straightforward despite this kind of scary looking general formula that we have here. But basically what this is telling us is that each term of the equation is some product of a function of t, as we see an of t, and so a function of t and a derivative of the function of y, function y, yeah. So, and this kind of keeps on going until it reaches the zero derivative that we have here, and which is the plain y function, and at the end it just equals another function of t, g of t. It kind of makes more sense when we see some examples, so I'll pull some up to clarify. Okay. Oops. Okay, yes. Here are some examples that we have here. So I'm going to go through these and determine whether there are linear or not linear. So for the first one, we have t cubed y prime plus 2t y prime plus y equals cosine of t. So if we look through each term, we can see that we have a function of t times a derivative of y. The next term we have a function of t, 2t, times a derivative of y. And here we have just the zero derivative of y, which is just y itself, equals another function of t, say g of t, cosine of t. So thus it follows our general formula that we have up here. So this we can call linear. Now for the next one, we have y double prime cubed plus 2y prime plus y equals 0. Now we can see that none of these terms are multiplied by a function of t. It's just all y and the derivatives of y, but there's no function of t like multiplied by the terms, so like something like that, which is something we need in each term. So this can't be linear, so not linear. And for the last one, we see we have cosine of y prime plus cosine of t equals 0. Here we see both a function of y prime and a function of t, but they're not products of one another. They're just kind of separate, so that can't be considered linear, thus not linear. So those are some examples of what first order linear differential equations are. Now that we know what they are, we can finally go ahead and try solving a few. So now the important thing to note about solving first order linear differential equations is that each equation has a general form and a standard form. This is the general form. So every first order linear DE is going to be some form of this, which is the general form, which is big P of t times y prime plus q of t y equals g of t. And this is the general form, and the standard form is y prime plus little p of t y equals little g of t. So this is pretty important because when we are solving for first order linear differential equations, we want both sides to be integratable. So if we try to integrate the general form, so this one right here, it would be pretty hard because we have all these annoying other functions of t kind of bothering us. So we want to isolate the y prime. So we use the standard form to do that. So with the standard form, we can make this whole function on both sides integratable. But how? Let's take that out. We want to make both sides of this function integratable. And by doing that, we can take this y prime and turn it into a y. And that way we can have our solution, our general solution of y. And that's exactly what we're going for. So how exactly do we make the standard form on both sides integratable? Well, we have an interesting thing called an integrating factor, which is defined by I of t equals e to the integral of p of t dt. And this p of t is what we got from the standard form. This is why the standard form is so important, because we need this p of t to find our integrating factor, which we will multiply both sides of the standard form by to make each side integratable. Thus we can make the y prime here a y, and thus we can solve the entire equation. That sounds like a lot, but I have written down the steps down here to kind of clarify everything, kind of like the to-do list that we need to do, which happened, sorry. The to-do list of solving first order DEs. So the steps are, number 1, check if your equation is in standard form, because that's important because we need to find that p of t. And 2 is find the integrating factor using p of t from the standard form. And third rule is to multiply both sides of the equation by the integrating factor that you just found. 4 is to integrate both sides, and 5 is to finally solve for y.